there are a lot of things about the universe that I find difficult to grasp, impossible, actually. One of them is size and scale. Imagine standing on the edge of an infinite abyss that stretches in all directions, further than the eye can see. How would you feel? Brian Cox just announced the true size of the universe, and it's mind-blowing. The British physicist brings us closer to the immense size of the universe with his very own thoughts and shows us in a unique way how fantastic all the objects and phenomena of the universe really are. Numbers such as trillions of galaxies and distances of billions of light-years are actually beyond our human imagination. Brian Cox, it is impossible to imagine the true size of the universe. We begin our journey through the unimaginable sizes of the universe in the tiny interior of an atom. A place that is paradoxically both full and empty. Imagine an object the size of a peach inside the Earth, and then perceive the distance between the peach and the outer shell of the Earth. This corresponds approximately to the distance between the nucleus of the atom and the outer shell of the atom. Only a few tiny particles orbit inside the atom, and the rest is simply a vast nothingness. This idea illustrates the incredible emptiness that makes up most of an atom, and we also find this emptiness and this incredible scale in the vastness of space. When we look out into the cosmos, which appears rich and full, we think we see matter, but there is actually much more nothing. And what we can see consists of atoms, inside of which there is virtually nothing. Nevertheless, we see shining stars, cosmic nebulae, and billions of galaxies with countless stars. Everything we can see is created because atoms combine to form molecules, through elementary forces. Molecules form elements, and all matter is created from these elements, from the smallest grains of sand to gigantic stars and planets. A single star like our Sun is estimated to consist of 10 to the power of 57 atoms. This number is a 1 followed by 57 zeros. Like the distances in the universe and the incredible structure, this number is so large that we cannot imagine it in a three-dimensional or linear form. Between the stars and planets stretches the immeasurable emptiness of space. The distances between stars are measured in light years, where a light year is the distance that light travels in 1 year, and expressed as a number that is about 9.46 trillion kilometers. In this enormous void, we find an unimaginable number of stars and galaxies, and scientists are still not quite sure whether this void is really empty. It could conceal other forces, elements, and very probably even forms of matter that are invisible to our eyes. Here too, the universe quickly takes us to the limits of our imagination. God can only be big, huge, and infinite. Brian Cox, in the visible part of the universe, there are something like 2 trillion galaxies. We haven't counted them all, but that's an estimate based on surveys of the local universe. 2 trillion, 2,000 billion galaxies, and we're very sure that this part that we can see is a small part of what could be an infinite universe beyond. Let's continue traveling through the incredible dimensions of the universe. We continue our contemplation with the immeasurable diversity and beauty of galaxies. Through their light, the universe becomes visible to our eyes, and they confront us with an elusive and breathtaking splendor. Each galaxy is like its own universe of stars, planets, and other cosmic phenomena. Of the 2 trillion galaxies mentioned by Brian Cox, we have only explored a fraction, but even this small section reveals an incredible diversity. No 2 galaxies are exactly alike, each is unique in its shape and composition so that every star and every planet within the galaxies occurs only once in the universe. The shapes are similar, there are spirals like our Milky Way, elliptical giants, and irregular formations. But on closer inspection, each galaxy is different and tells its own story with its development. Some of the most famous and impressive galaxies include the Andromeda Galaxy, our nearest large neighboring galaxy, the majestic spiral galaxy M51, also known as the Whirlpool, and the unusual ring galaxy, Hogg's Object. The number of stars in each galaxy varies enormously, from a few million in dwarf galaxies to hundreds of billions in larger ones like the Milky Way. If you multiply these numbers, you arrive at an almost unimaginable number of stars in the entire universe. And each of these stars may have planets orbiting around them, some of which are similar to Earth and could harbor life. Galaxies perform a constant cosmic dance. They are not static. They are constantly moving through space at incredible speeds, sometimes meeting and interacting with each other. Galaxies can collide and merge, leading to spectacular cosmic events that last for millions of years. The images we get from telescopes like Hubble and James Webb show a world of colors and shapes that truly surpasses our imagination. Brian Cox, are we the creators of this beauty? We are the conscious universe, and life is the means by which the universe understands itself. It sounds crazy, but maybe the universe only exists because you and I are here. Once again, the brilliant physicist Brian Cox puts it in a nutshell: our consciousness shapes the universe, and it comes alive with and through us. We are witnesses to an immeasurable ocean of light and darkness, and quantum physics teaches us that none of this would exist if it weren't for us and our human consciousness. In the immeasurable vastness of the universe, humans seem almost insignificantly tiny and small. Imagine how small a human being is compared to a mountain, an ocean, or even a planet. But Brian Cox warns us not to get caught up in the contemplation of size or let it deceive us. We humans are of crucial importance as observers of this cosmic splendor. There are theories that all of this was created for us to perceive and explore. It has often been speculated whether space itself has a kind of consciousness. If we look at the beauty of the cosmos, its infinite stars and galaxies, the geometric shapes and splendor, it cannot be a coincidence. There is a blueprint, and possibly a purpose. Consciousness cannot yet be fully explored. We can measure brain waves, and these change when we look at certain things, when we feel emotions, or when we imagine the infinite vastness of the cosmos. But we don't know whether the universe is also watching us, and whether there is an intelligence out there that may be the one great creator of all this splendor. Maybe it's calling out to us, "Hey, look, this is me, and I created this, and you are part of me." Is the dawn of humanity imminent? If we believe visionaries like Elon Musk, we will soon no longer be satisfied with just contemplating outer space. We want to travel and conquer the universe. What has long been a reality in science fiction films will soon be possible. Travel between planets will certainly be mastered in the next century, and we will also make the leap beyond the boundaries of the solar system. Humanity is facing a challenge, and we will master it. The distances in space are so enormous that even the idea of traveling through our own galaxy, the Milky Way, is currently difficult to imagine. A spaceship traveling at the highest speed we can currently achieve would take thousands of years just to reach the nearest star. Even light, traveling once across the Milky Way, would take 100,000 years to cover that distance. However, our history teaches us that what seems impossible today can become reality tomorrow. Our curiosity, our inventiveness, and our unwavering will to explore the unknown have already led us to incredible achievements. 200 years ago, no one could have imagined a television or a smartphone. Now we are already building spaceships that can fly to the moon, and scientists are working on new concepts for faster-than-light travel. The warp drive and the folding of spacetime are just a stone's throw away. Huge and tiny, we have looked at the world from small to large, at the massive phenomena, the gigantic void, and explored our own existence in this gigantic space. Let us now travel together into the macrocosm and the microcosm. At the very top of the scale of the largest phenomena in the cosmos, we encounter the Shapley supercluster. At a distance of 650 million light-years, there are more than 8,000 galaxies in one cluster. But it gets even bigger. The Lanaka supercluster, to which our Milky Way also belongs, is a huge structure that stretches over 500 million light-years and has the weight of 100 million billion suns. The Great Wall of Sloan, which stretches over 1.37 billion light-years, proves that it can be even bigger. These structures are made up of countless galaxies, galaxy clusters, and other cosmic objects that wander through the universe along huge filaments. In the midst of these colossal structures, we also find individual objects of unimaginable size. Take the hypergiant Scuti, for example, which is one of the largest stars, with a radius around 1,700 times larger than that of the Sun. If Scuti were placed in our solar system, it would extend far beyond the orbit of Jupiter. And then there are the black holes, the mysterious objects whose gravitational force not even light can escape. The supermassive black hole at the center of the galaxy M87, known as M87 star, has a mass 0.5 billion times greater than that of our Sun. In the world of the smallest objects and structures, we are fascinated by particles so small that they are beyond our imagination, due to their complexity and the laws of quantum physics, which have so far been difficult to understand. In this microcosm, we find particles that behave so strangely that they completely turn our concept of space, time, and matter upside down. At the heart of the atom, in the atomic nucleus, we find protons and neutrons, which in turn consist of even smaller particles, quarks. Quarks are some of the most fundamental and smallest building blocks of matter, occurring in 6 different types and forming bonds through strong nuclear forces that make matter possible. Even smaller is the Higgs boson, also known as the God particle, which is another fundamental building block of matter. However, the Higgs boson itself is so fleeting that researchers can barely get their hands on it. In the world of quantum physics, we also encounter neutrinos, ghostly particles that are almost massless and fly through the universe in huge quantities. Neutrinos pass through our bodies and other objects without interacting with matter. We still know very little about the function of these particles, but neutrinos act like messengers, and their behavior reveals details about fundamental processes in the universe, such as nuclear fusion. If we leave the world of visible matter, we come to the phenomena of dark matter and dark energy. Together, the two probably form a completely separate universe, a dark counterworld to our visible world, where completely different physical laws may apply than in the visible world. Become a subscriber now, and never miss a new video.